as you look at this, that since I already have most of the basic stuff already kind of filled in for you, I kind of have zero patience for people not taking notes, because I do try to make it as easy for you as possible, so you don't have to write every single thing down. So just stay with me. When I was going through your goal sheet you filled out Friday, a lot of you guys said, take your time, don't go too fast, do examples, explain it well. I need you guys to let me know if I'm not doing that well while we're doing those. So if you don't understand something, if I'm going too fast, if I'm talking too fast, let me know. Just interrupt me and say, hey, can you explain that again? Can you slow down? I didn't get everything down. I'm not going to be upset if you let me know. Just interrupt me and say, hey, repeat this, or I missed that. Because I can't tell. With 30 people, it's hard for me to tell to make sure that all you guys are getting it and on task. So just let me know if you need help me to slow down. I also teach calculus, so I teach Algebra 1 and Calculus. So it's a different, explaining stuff to my calculus kids and explaining stuff to you guys is a whole different ball game. So let me know if I'm not explaining something well enough, and I will be sure to kind of re-explain it. Okay, so let me know with that stuff. As I'm looking at these notes, I'm trying my best to make these very similar to the homework, and you will see that when I give the homework. It annoyed me as a student when we took notes and then it looks nothing like the homework and you expect me to do the homework and I don't know how to do it because the notes look nothing like it. So I try to be very intentional about making the note packet look similar with the same directions as the homework, and we'll look at that when we go over the homework. So let me know if you need me to slow down, if you need me to kind of repeat stuff. So what we're looking at today is we are classifying numbers. So we're taking numbers and we're going to classify them using a couple different subjects, I guess. So first thing we have is a real number, and that is R. And a real number is any number. So any number that you have dealt with, and I'm going to use the hashtag symbol to represent number. So a real number is any number you've dealt with up to this point in your math career. In Algebra 2, you will get to imaginary numbers because you know it's not hard enough. But as of now, any number you deal with is a real number. After real number, it can either be irrational or rational. So it splits off into two. An irrational number is represented by the letter I. So I give you these abbreviations so you don't have to write all of these big words down. An irrational number is a decimal that never ends and has no pattern to it. So a kind of mumbo-jumbo number. Another thing it is, if you need to make kind of a note down here, it is non-perfect square roots. Kind of like we talked about on the warm-ups. Perfect squares are numbers that you can take the square root of. Perfect square was the word I was looking for. Square root of 25 is what? 5. Square root of 64 is 8. Those are perfect square. A perfect square is a number that you can take the square root of and you get a whole number back. Non-perfect square roots would be numbers you can't take the square root of evenly. So for example, what's a non-perfect square root? Square root of what? 82. That's not a perfect square. Okay, I cannot take the square root of 82 and get back a whole number. So any non-perfect square root is a rational number. Any decimal that repeats, what's the most famous never-ending decimal? Pi. So anything with pi, whether it's pi or 2 pi or pi over 4 or whatever, anything with pi is a never-ending decimal. So that is irrational. Okay? So irrational numbers, non-perfect square root or never-ending decimal. Okay? Next one we have, so it's either irrational or rational. Rational, we represent with a Q, which is kind of random, but I'm going to kind of give you a little kind of easier way to remember that. A rational number, it's all fractions or decimals that end or have a pattern. So let's think about it. What word in rational kind of tells you we're going to be dealing with fractions. So what word in rational means the same thing as a fraction? Ratio. So that's how I remember that rational means a fraction, ratio. And we use a Q to represent it. So if ratio and fraction are the same thing, what operation is represented by a fraction? When I say operation, I mean add, subtract, multiply, or divide. So what of the four operations is represented by something over something? Division. And what's the answer to a division problem called? Quotient. That's how I remember the Q. Q, think of quotient, and quotient is something divided by something, or a fraction. So that's kind of how I remember the Q. So any fraction, 1/3, is a quotient. It's a division, something over something. That is a fraction. That's a rational number. Any decimal that ends, so 0.32 would be a ending decimal. It ends. It doesn't repeat. Okay. Any decimal that has a pattern, so that means it can repeat. So how do I represent a repeating decimal? Do I remember? Yeah. Perfect. So if I had negative 2.67 with a line over 0.67, or the 6/7 part, that is a repeating decimal. So since it has a pattern, 6/7, 6/7, 6/7, 6/7, that is a rational number. And we can also have, like if I have negative 2 4/5, even though it's a mixed number, it is a fraction, so it is a rational number. How about a whole number? Is a whole number, so like is the number 5 a rational number? Can I represent a 5 as a fraction? How can I represent 5 as a fraction? Put it over 1. So any whole number you can put over 5, or sorry, you can put over 1, and it is a rational number. So any whole number is a rational number. How else could I represent 5 as a fraction? So 5 over 1 works. How else can I represent 5 as a fraction? I'll give you a piece of candy for this one, because no one got a piece of candy the first time. How else can I represent 5 as a fraction instead of 5 over 1? Yes? And that's 1/5, but nice try. How can I represent 5 as a fraction? Remember, a fraction is division. It's the same thing as division. So think about what two numbers could I put something over something that would divide to give me 5? Yes?
25 over 5.
Yeah, 25 over 5. So we can represent, I'll get you candy in a second. We can represent 5. You might see it represented as like 5 over 1 or 25 over 5. So if you can reduce the fraction and divide it and get a whole number, that's fine. So there's lots of different ways you may see the number 5 represented. Okay. Questions on all those examples? That's rational. If it's rational, then there's 3 other things you have to check. You have to first check if it's an integer, which we use z to represent it. I have no idea. There's really no way to remember that. Integer z. That's what it is. So an integer is no fraction. That movie's loud. Or a decimal. So an integer, for a number to be an integer, it cannot have a fraction or a decimal part. Pretty plain and simple. So -3, -2, -1, 0, 1, 2, 3, those are all integers. The negative, it's allowed to be a negative. They don't have a fraction or decimal part. So if it's a decimal or a fraction, it's not an integer, unless you can simplify it. Okay, after integer, then you need to check and see, is it a whole number? Which finally, it's just a W. So whole number is no negative. So for it to be a whole number, it cannot be a negative. So only 0, 1, 2, 3, dot, 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 which means 4, 5, 6, 7, 8, on forever. So a whole number just can't have a negative. And a natural number, which is sometimes referred to as counting numbers, because we use an n to represent it. If you think back to when you started counting, if you don't know how to count, we have bigger issues. But when you first started counting in like kindergarten, what number did you usually start with? 1, 2, 3, 4, blah, blah, blah. So a natural number or a counting number has no zero. So you can kind of notice that if it's rational, you check if it's an integer, and then check if it's a whole number, and then check and see if it's natural. And there's kind of specific things for each one. Does that kind of make sense? Any questions on that? Do you remember doing this in the middle school? Maybe sort of? It's not something you use a ton, but you might have seen it. Okay, we're going to skip the bottom part for now. And we're going to look at example 1. So if I look at example 1, these are going to be the directions, the same type of problems that are on your homework. So example 1, name the set or sets of numbers to which each row number belongs to. First one we have, part A, example A is 9/10. So it's a fraction, 9/10. So we need to classify it. So as I look at the map, so on the first page, if you look at the map, you can just look up here if you don't want to flip back and forth, it's up to you. We start with real number. All numbers are real numbers, so we're going to put an R. Now, the book doesn't really classify it as real numbers, so if you're checking your answers in the back, the odds, they may not put an R first. I don't really care, because they kind of are assuming everything's a real number. So then I asked myself, if I look at the map, is it rational or irrational? So as I look at it, well, irrational is non-ending decimals or non-perfect square roots. Rational are fractions or decimals that end. So is 9/10 irrational or rational? Rational, it's Q. You can just put a Q because it's what? It's a fraction. Ratio, rational, fraction. So it's a fraction, so it's rational. So I put a Q. Now I have to check, is it an integer? So integer cannot have what? Fraction or decimal. So does 9/10 have a fraction? Yes, because it's a fraction. So we're done. Since it's not an integer, we are done. We don't have to check anything else. So it is real and it is rational. So that kind of makes sense. Okay, let's look at B real quick. If I look at B, square root of 121. What do you notice about 121? It's on the warm-up. So what is the square root of 121? 11. It's a perfect square. So we can simplify it to 11. So if it's a perfect square, simplify it to 11. And now let's start classifying it. I know it's going to be what? It's real. So you can put an R first if you want to. And now I need to check if it's irrational or rational. Is 11 irrational or rational? Look at your examples if you need to. Any takers? Thoughts? Rational or irrational? Rational. Any whole number is rational because I can always make it a fraction by putting it over 1. Even though it's a square root, it's a perfect square root. So it simplifies down to 11. Next thing I need to check is an integer. An integer cannot have a what? Decimal or fraction. Does 11 have a fraction or decimal? No, it's a whole number. So it's an integer. Then I go down the list. The next thing to check is whole number. Whole numbers cannot have any negative. Well, is this a negative? No. So it's a whole number. And then I need to check the natural numbers. Natural number doesn't include what? Is this 0? No. So it's a natural number. So natural number is easy to check, because as long as it's not 0, then you know it's natural. Any questions on that one? Okay, let's look at C. As I look at the square root of 18, can I actually take the square root of 18 and get a whole number? No, so I'm just going to leave it. So first thing I'm going to look for is, it's real. I know it's a real number. Is it irrational or rational? Irrational, because it's a non-perfect square root. It doesn't simplify. So it is irrational. Do I need to check anything else? No, because there's nothing underneath irrational. So it's real irrational. And let me do one more example of this type with you. If I had 36 over 9, there's some on the homework that first block was having issues with. If it's 36 over 9, even if it gives you a fraction, check to see if I can reduce it. What does 36 over 9 reduce to? 4. So if it's a fraction you can divide it out before you start classifying it. Now, it's real. Is it rational or irrational? Rational, because any whole number is rational. Integer? Yes, no, maybe? Yes, there's no fraction or decimal part. Whole number? Whole number can't include what? Negatives. It's not negative. Natural numbers can't include 0. It's not 0, so it's natural. So what can you conclude about any positive number that doesn't have fractions or decimal? If I look at 4 and 11, what can you conclude about whole numbers or numbers without fractions or decimals that are positive? They're going to be what? Any takers? All 5. They're real, they're irrational. We're on the top of the second page. They're going to be real, rational, integer, whole, and natural. So any positive number without a fraction or decimal that's not 0 will be all 5. Okay? So go ahead and take a couple-minute break real quick. You have a few more notes to take, but I don't want to do a ton of notes. So go ahead, or a ton of notes in a row. So take a couple-minute break. You can talk with your partner, relax for a couple minutes, and we'll finish these notes. If you have questions over those, let me know. Now, I forgot to mention this earlier. These notes are your notes. I want you to take them all, but I don't really care what you write them in. So if it's easier for you to take notes in pen and use different colors for different things, I don't really care. It's up to you. So your notes, as long as you're taking them, I don't really care what you're writing them in. Besides Sharpie, don't use Sharpie. It just annoys me because it bleeds all over. So your notes are your notes to take. You can use pen. Homework and test, I want done in pencil. Because you're probably not going to you're not going to make mistakes on the notes unless I do it wrong. So you can choose what you want to do. Yes?
You and Miss Bowman do the exact same thing.
Do we? This?
Yeah, it's a whole...
Yeah. I think are they the same note?
Yeah.
Are they?
Exact same.
Oh, nice. There you go. So, there you go. We do it different ways. Did you like how she did it?
Yeah.
Okay. Good answer.
Bowman from the middle school.
No.
She's an English teacher.
Yes. I don't know. Is she 8th grade English?
I think she changed to 8th grade.
Okay.
I'm not
never had
sure
her.
it's someone in middle school at the moment.
Yes, I don't know. I never had her.
It's 14th, right? I just want to make sure.
No, you're good. Yep. Yes.
No.
I can give it to you when we start homework. Remind me. Yeah, I can give it to you. Okay, let's go ahead and finish these notes. I want to give you some time at the end to be able to start the homework. So example 2, I want to graph each set of numbers on a number line, then order the numbers from least to greatest. You can cross out the last sentence. You don't have to worry about ordering them from least to greatest. So on the homework, those directions will be on there. You can just ignore them. Because when you put them on a number line, they're already going to be from least to greatest, so it's kind of redundant to have to write them again. Okay? So as I look at putting them on a number line, it's easiest if you kind of get them all in the same form. So if you make them all a fraction or all a decimal. I don't really care. If you do decimals easiest, you can convert them all to decimal first if they're fractions, and then graph them on a number line. I'm not going to be picky. So as I look at A, I have 4 numbers here, 4 fractions. So as I look at this, as I draw my number line, you don't have to write every single number on there. You just kind of have to look at the 4 numbers they give you and try to kind of pick out the whole numbers that are going to kind of include all those numbers. So what I mean by that is as I look at this, as I look at these 4 numbers, what is the lowest number that's going to that I have to put on my, what's the lowest whole number that I have to put on my number line? So what's the lowest number I see on here? Do what? The negative, lower than that. Negative what? 1.5. Since that's the lowest number, we're going to put a -2 first. You don't really have to include anything lower than -2 because we're not going to go past -2. So kind of make your number lines don't make sense with your numbers. -1, 0, 1. Do I have anything? This kind of gets tricky. We're going to put a 2 here, and that'll make more sense kind of as we look at my numbers. Okay? So kind of put the whole numbers on your number line, which makes sense with the numbers they give you. So as I look at 3/4, I need to put that on the number line. So anybody kind of think about where I would put 3/4 on the number line? Is it going to be past 1? No. By looking at 3/4, why would it not be past 1? Yes.
Because it's not 1 and 3/4.
It's not a mixed number, yes. Or what else? Even though it's not a mixed number, how could I tell that 3/4, 3/4 is not going to be over 1? What number over 4 represents 1? 4/4, yeah. So if I have 4/4, that's 1. So any number bigger than 4 on top means you're going to be over 1. So since this 3 is less than 4, it's going to be between 0 and 1, a little closer to what? 1. So it's going to be between 0 and 1, a little closer to 1. So 3/4 right there. Like I said, if it is easier for you to convert them to decimal first, convert them to decimal. How do I convert 3/4 to a decimal? Or you might know what 3/4 is as a decimal. 0.75. So if it's easier for you to think about them as decimal, then convert them to decimal. Okay? I'll show you how to do that on a calculator in a second. -1/4. So if I think about -1/4, that's going to be between which 2 numbers? -1 and 0. Is it going to be closer to -1 or 0? 0. So it's going to be closer to 0. So -1/4. And if it's helpful for you to convert it to decimal, it's -0.25. Okay? Now 7/4 is tricky. That one's hard to kind of think about. So a couple options you can do here. I'm going to show you options and you choose whichever one's easiest for you. 7/4. So grab a calculator. If you don't have a calculator with you, go grab one up there. So you can kind of do it with me. and I want to turn 7/4 into a decimal. So how would I turn 7/4 into a decimal? Any taker? 7/4 decimal? Yes. Yeah. So take the top number divided by the bottom number, and you're going to get 1.75. So that's one way to convert it to decimal. How else could I write 7/4 so it'd be easier to see on the number line? So how could I write 7/4 as a mixed number? Remember how to do that? Yeah. 1 3/4. How many whole times does 4 go into 7? 1. The remainder is 3. So 1 3/4. Either way is fine. I don't care, whichever is easiest for you. If you want to divide it and get a decimal, or write it as a mixed number, I don't care. So if I look at 7/4, 1.75 is going to be between what two numbers? 1 and 2, closer to 2. So 7/4. Right there. So it's easier to convert it either to a mixed number or a decimal, so you see what number they're between. -1.5 isn't as hard because it's already a mixed number. So -1.5 is going to be between -2 and 1, and basically right in the middle. So I'm not going to be picky if I'm like, it doesn't look like it's in the middle. As long as it's close, that's fine. Okay, any questions on that one? Okay, let's go ahead and look at B. We're not going to do C. Let's look at B real quick. Okay, let's simplify them. Let's get them all so I can actually see what number they represent before I put them on a number line. Square root of 25, 5. 25 is a perfect square, so that's just 5. 4.6 line over the 6 means what? Yeah, so 4.667 basically, because it's going to repeat and then I just rounded it. Now, square root of 15, is 15 a perfect square? No, so plug it in your calculator. Just get a decimal and then graph it from there. So if I'm graphing a square root, or if I'm putting a square root in my calculator, the square root button, if you look, if you're not familiar with these, is right above, it's in blue, right above the x squared button. So how do I get the blue part of that button? Yeah, second x squared. So if you press second x squared, you're going to get square root and then 15. And that will be 3.87. So you don't have to round to 4 or 5 places, as long as you can kind of tell what numbers is between. 3.87. And then I have 4 3/8. So if I look at 4 3/8, I want to get that as a decimal because it's easier to think about. The 3/8 is kind of confusing where it's going to be. How do I do 4 3/8 as a decimal? Yes?
35 over 8.
You could get it into a mixed number as 35 over 8 and then divide it out. That's one option. Or you could even do a little easier. Instead of making it an improper fraction and dividing it out, what could I do? What's my whole number? 4. So it's going to be 4 point. How do I figure out what comes after the decimal? 3 divided by 8. So 3 divided by 8 is 0.375. So 4.375. So I don't care. Get everything into decimal if that's easiest for you, and then graph it that way. Okay, now let's actually graph it. I think decimal is easiest to do a number line with. Okay, number line. Pick the lowest. What's my lowest number I have? 3.87. So I'm going to start with 3, 4, 5, and I need a 6 because I have 5 point. Well, actually 5 would have been fine, but that's okay. Okay. So as I look at graphing these, decimal makes it a little easier. So as I start graphing these, we have, let's see. So I'm just going to put a point. That should work. Yep. Let's go ahead and put a point on 5. 4.667 is going to go where? Between 4 and 5, a little over halfway. So 4.6 repeating. I'm not going to be super picky. 3.87. Between 3 and 4, closer to 4. And 4.375 will be about right there. Okay? Any questions on that? Okay, that's probably the trickiest stuff we'll do today. So I hope the other stuff kind of is easier for you guys. Okay, we're skipping example C. Go ahead, example 3 we're going to cross out. We're not doing example 3. There won't be any on the homework like it. We're going to skip those ones. And we are going to look at simplifying perfect squares. So perfect square, let's go ahead and write them out so they're all on your sheet for you. Square root of 1. What's square root of 1? 1. What's my next perfect square? So 1's a perfect square. The next perfect square is 4. Square root of 4 is 2. Next perfect square is 9. Square root of 9 is 3. So the perfect squares are numbers I can take the square root of. So I'm just writing them in the notes so they're there so you don't have to like flip through pages to figure it out. Next one is square root of what? 16, which is 4. So the next perfect square is 16. Next perfect square is square root of 25 is, yep. Next perfect square is 36. Square root of 36 is, yep. Next perfect square is square root of 49 is,
7.
Yep. Next perfect square is 64. Square root of 64 is 8. This might be kind of redundant, I know, but I like putting it in the notes so they are there so you don't have to flip. So everything is in one spot when you look at your homework. Next one, square root of 81 is 9. Square root of 100 is 10. We'll do a couple more. Square root of 121 is 11. Next perfect square is 144. Square root of 144 is 12. Square root of 169 is 13. And the square root of 196, I believe, is 14. So those are my perfect squares. 1, 4, 9, 16, 36, 25, blah, blah, blah. So they're all on there, at least most of them. So as we're working with these perfect squares, these are kind of the numbers you want to remember because I can take the square root of them. So as I look at my first, let's look at example 4. I want to simplify each square root. If I'm simplifying this, we have the square root of 64 over 16, and that's for lunch. So if I am taking the square root of a fraction, all you do is just take the square root of the top and the bottom separately. So if I'm taking the square root of the fraction, all you do is take the square root of the top and the bottom separately. Now, what is the square root of 64? What is the square root of 16? 4. So those are perfect squares, so I can actually take the square root, and 8 over 4 reduces to what? 2. So 2 is your answer. Sometimes you'll be able to reduce it down, sometimes you won't. Next one, let's separate them first. So negative square root of 25 over square root of 144. Square root of 25. Yeah, I have that negative. So negative 5 over. Does that reduce any? Nope. So that is your answer. Okay. If you get a sum on the homework will be like this, like a decimal. You'll have a square root of a decimal. Just like use the calculator. If you get the square root of a decimal and it says reduce it, just plug it in your calculator. So square root of 0.064. Is that right? Yeah, just get a calculator. 0.25 is fine. So if they give you a decimal, just use your calculator. With some of the homework like that. Okay, last section. We're taking more notes today, sorry, because we didn't have homework to go over. Okay, example 5. Estimate each square root to the nearest whole number. Do not use a calculator. Okay, you can do it without a calculator. All you're doing is estimating, so it doesn't have to be any decimal part. So what you're going to look at is you're going to look at 34. Is 34 a perfect square? No, but what perfect squares is 34 between? Well, perfect squares though. 25 and 36. So I want to know what perfect squares is 34 between 25 and 36. Now, if I'm going to estimate, 5 is 25, 36 is 6, is it going to be closer to 5 or 6? 6, because 34 is closer to 36. So if I estimate it, my estimation is going to be 6. Does that make sense? Pick the perfect square below it, above it, and then choose which one is closest to. So if I look at B, what perfect square is below 97? 81. What perfect square is above 97? And which one is it closest to? So my estimation is 10. Does that help? Okay. Homework, you're going to get some time to work on it, more than first block actually. So, if I look at my homework, it is page P10. So not page 10, it's page P10. 1 through 18, 23 through 35. So this week you're getting maybe more homework than I might assign if once we get into like normal algebra stuff, because some of it doesn't take much work. It's just pretty repetitive. So page P10, 1 through 18, 23 through 35. So go ahead and get your books out. Get out a piece of paper, turn to page P10, and I'll look at these with you real quick. Go ahead and keep your notes out as well. Yes, sir.
I don't have a book.
Did I not get you one yesterday?
I wasn't able to.
Oh, okay. Well, then you need to do the pre-test too. Yes, come up and grab a book. This one. It's in rough shape, but it should work. One on that. I'll write it down. Yes.